Today we are going to solve literal equations. Literal equations are any equation that has more than one variable. We see literal equations in science a lot and in math and geometry dealing with different formulas. And what we are going to do is we are going to change the equation around so that we can solve for one particular variable. So any equation that contains more than one variable can be solved for any of the variables. Solving for a variable means to isolate that variable on one side of the equal sign. An example is D equals RT. This is a science formula. Distance equals rate times time. You can manipulate this equation to say one variable equals another. So back in 8th grade science, you might have seen this triangle. Go ahead and draw that triangle on there. And this is the distance, rate, and time triangle where you can change around DRT. That's what I said. And the way this works is D equals RT. And the same equation, but solve for a different variable, would be R equals D over T. Or you can say T equals D over R. So these equations are all similar and they have the same variable and they can be solved for different variables. So solving for a particular variable is helpful in math and science because that variable might represent the information that is needed. Solving literal equations is just like solving regular equations. Variables can be moved from one side to the other just like numbers are moved. And you move by doing inverse operations. Remember, add, opposite is subtract. Multiply, the opposite is divide. Squaring something, the opposite is taking the square root. So inverse operations help you move the variables. The only difference is that since numbers aren't being used, there will be little to no simplification. So combining like terms and all of that. We are going to use a highlighter. So look in your buckets and go ahead and get a highlighter out. And we are going to highlight the variable you're solving for. So we are going to solve an equation that has only one variable. So you can see the process. Then we're going to solve another equation that has more than one variable. So this says solve for x. So the variable that we're solving for is x. So I'm going to highlight x. Draw your line down your equal sign. And to solve for x here, you would do the inverse of what's happening to x. So 2 times x. So the inverse operation would be divide both sides by 2. Two divided by 2 is 1, so it simplifies out, and we get x equals 8 divided by 2 is 4. That's our solution. We've done this before. So now we're going to look at it where you have every term is a variable. We're going to solve for h now. So same process. Draw your line down your equal sign, and you look and see what is happening to the variable in question, which is h. It's being multiplied by b. So the opposite of multiplying by b is dividing both sides by b. The b's cancel just like the 2's cancel because b divided by b gives you 1. So we're left with h equals volume divided by base. So we have another equation as our answer because we're rewriting it. Okay, let's look at this one. Solve for r. Oh, we got to highlight R in the equation also. So this is circumference equals 2 pi R. So we look and see what's happening to R. It's being multiplied by 2 and by pi. We can actually get rid of both of those at the same time because it's multiply all the way through. So you can divide by the 2 pi. Whatever you do to one side, you have to do to the other. 2 pi's can be canceled. And I'm going to rewrite it and put R equals C over 2 pi. Okay. Let's look at the example on the bottom left. Compare the steps to solve the two equations. Okay, so this says solve for x. So go ahead and highlight x. So x divided by 3, and we want to get it equal to 5. So we look and see what's happening to x. It's being divided by 3. The opposite of dividing is multiplying by 3. So then the 3's cancel, and we're left with x equals 5 times 3, 15. So this problem is similar to this one. We're solving for the variable on top. Solving for the f. We're going to multiply both sides by the denominator. This is a science formula. Force equals mass times acceleration. I'm just going to put ma because that's m times a. So now we're going to solve for b. We need to get rid of both half and h. So we can get rid of half first. What's the opposite of multiplying by half? Remember with a fraction, my favorite word? Reciprocal. We're going to multiply both sides by the reciprocal, 2 over 1. Because 1 over 2 times 2 over 1 equals 1. The reciprocal. 1 over 2, the opposite would be 2 over 1. Remember, you're always doing opposite. So this and this cancel, and you're left with 2a equals bh. But we're not done yet. We're still trying to solve for b. So go ahead and highlight b again because we're not done. So this is multiply, so the opposite would be to divide by h on both sides. Then I'm just going to rearrange and just say b equals 2a over h. So we just had 2 more problems to do, so let's look at those. We're solving for h here. Highlight them. Okay, we have a equals b times h. This is multiply. We can divide by b to get h by itself. When you do that, the b's will cancel. And you just have h equals a over b, so I can rewrite it. A over b. So a divided by b. Okay, the last one we have w. We need to get W by itself. So we look and see what is W being by. So we need to get rid of this 2L. So this is perimeter formula. Perimeter equals 2 times L plus 2 times W. We need to get rid of this 2L. So we're going to subtract. You can't combine those because one has a P variable, one has an L variable. So we just rewrite it kind of like the LMX plus B. I'm just going to bring down that 2W. 2 times W, we need to get rid of what's in front of W, which is 2. So we're going to divide by 2 all the way through. 2's cancel here and there. And we're left with P over 2 minus L equals W. Yeah, this one's a long one. Go ahead and rearrange it and do W equals P over 2 minus L and put a box around it. Okay, I do want to give y'all one more. So put solve for X in the equation Y equals X squared. It's a exponent. So in order to solve for X, you're always doing inverse operations. So the operation that's happening to X is squared. So you do the opposite. The opposite of squaring something is taking the square root. So if I have 5 squared, I get 25. If I want to go the opposite way, 5 squared is 25. If I want to go the opposite way, I would take the square root of 25 to get 5. So that's what we did here. If we want to find out what y is, we would take the square root. So x equals the square root of y. So the opposite of squaring something is taking the square root. I'm going to tell you what you're going to do on your assignment now. You're going to glue this in on the next page. Dot, dot, null. Page 14.
You finna do the assignment?
So let's look at the assignment. This is one side of the page. And go ahead and write your name and your class period on here. And the instructions say, solve each equation below for the indicated variable. Show your work in the second column, then circle your solution and color the design below. So you're going to solve for W. So rewrite it. So area equals length times width. Then use your highlighter to solve for the variable. So we're solving for a W. If we want to solve for W, we need to get the L to go to the other side. Operation here is multiply. So we would divide by L on both sides. And I always do a cursive L, otherwise it looks like a 1, so that's why it looks like that. And then you look at your answer choices and see, your answer choices are these. So it's 1 and 3.
So it'd be yellow.
So circle it, box it, whatever. And then down here, if you want to, for extra credit, you can color in all the ones for yellow. So there are 8 problems like this where you work it out, show your work, and then pick your solution. The back, you're just going to choose any 5. To do. You don't have to do them all. If you want to do more for bonus points, you can.
I think I might do all of them.
Okay, so that is all. You have the rest of the class period to finish this. Whatever you don't finish is homework.